Hello everyone, I'm Johara from 3rd year EC. This is our digital communication project and we developed it as a team of 8 members. We have created a web-based simulator with all the necessary ways to make it look beginner friendly, especially for the upcoming juniors to dive into concept more practically rather than learning it theoretically. And here we are demonstrating amplitude shift keying, commonly known as ASK modulation. ASK is a digital modulation technique where the amplitude of carrier signal keeps on changing based on the binary input that the user gives. When the input bit is 1, the carrier signal will be present, and when the input bit is 0, the carrier signal will be absent. This method is very simple and it helps in understanding the very basics of digital communication. To build this virtual lab, we have used HTML and CSS. HTML for the basic framework of the page and CSS for the styling of the web page. JavaScript for implementing the modulation and demodulation logics. Finally, to host this page online, we have used GitHub pages. Like you can copy the GitHub link and you just paste it in the browser or Chrome. You just run it and you get the ASK virtual lab. Now coming to our website interface, we have given all the provisions for the message amplitude and message frequency along with their carrier amplitude and carrier frequency. And there is also a provision for binary input sequence and there is an option to generate in random binary sequence as well. And we also given some basic rules. Not much though very difficult rules. We have specified the limit of specifying the carrier frequency and message frequency. That is, the carrier frequency should be 10 times greater than that of the message frequency. And you can give whatever values you want. Just make sure that you follow these rules and give the input binary sequence in zeros and ones. Once the values are entered, we generate the ASK signal. First, we can see the binary input waveform followed by carrier signal. Next, the ASK modulated signal is displayed. Here you can clearly observe that the carrier appears only when the input bit is 1 and disappears when the bit is 0. After the modulation signal, the demodulated output is also shown. This represents the recovered digital data, which matches with the original input sequence. This confirms that the transmission and receptions are done successfully. Let's give different modules of value and see how the waveforms differ from one another. And I am also attaching the screenshots for a very clear form of the waveform, and you can clearly see how the transmission and reception of the waveforms are done. When you click on the graph, you can see there are different options like zoom in, zoom out, and arrow symbol and so on. These are the inbuilt functions that are given by the plot.js. And lastly, on behalf of all our team members, I would like to express my sincere gratitude to Dr. Jayanti ma'am for her valuable guidance, support and encouragement throughout the completion of this project.